Okay, let us continue with our genetic algorithm. In this video, we are going to sort the lights based on how close they got to the goal. So for that, we have to make a goal. Just go into our sprites folder, grab the circle and drag it anywhere into the scene, and we name the game object to goal. And we are going to refer to the goal by a script called goal. We are not going to put anything inside there, so just right click, create C# script, call this one goal, and drag it onto the goal. And I can also get the goal and drag it onto the gate, so it's now a child of it, and get the gate, drag it into the prefabs folder. Okay, next off, let's open the light spawner script. Okay, we want to reference the goal by simply assigning it in the inspector. So serialize the field and say private goal. And to get the position, first off, we're going to make a vector2, private vector2, call it goal position. And in awake, we are going to say goal position equals goal.transform.position. And before we forget it, let's just save the script, go back into the and in our gate prefab, we can assign the goal, and that should just, if we go in here, override, apply all, and you see it's no longer bold. It just, whenever we're going to create a prefab, it's going to have a goal, and it's also going to know about that goal. So now we have the position. Okay, and next thing, we want our lights to know how close they got to the goal whenever they die in here. We're just going to check how close they are. So we want to have a score, and we are going to be using a property so we can make sure that anyone can know about it, but only the light can actually change that value. And so for that, make a backup field, call it score, hit Control period, and now it's going to suggest to use a property, hit enter. And this one's going to be public, but we can now change whatever we want to private. So change the set to private, meaning get is still public, but set is now private. And so when we die, we can say, and I just remembered that in the light spawner, of course, the goal position should be public because our light wants to read it. And technically, you could do exactly the same we just did here with the property. But I think we're only going to be accessing the goal position in this single line, so the danger of mixing things up shouldn't be too big. So let's just keep it simple and let the goal position be public. And in here, we're going to say score equals vector2.distance. We're going to pass in our own position. That's where we died. And of course, the goal position of our spawner. And so vector2.distance is returning a float, and we're assigning score to it. So now whenever the lights die, they have a score, and now we need to sort them based on that score. For that, we're going to make a new script. So later on, the script can do a bunch of other things, and we're going to call it cloner. Open it up. And this script is going to have one public function, which is going to return a list of light. It's going to be called next generation. And it's going to take in a reference of a list light called old generation. And I think we're going to make one private list in here. Private list, of light. call it new generation, and that is the one we're going to return. And in here, whenever we call that function, we're going to clear out the list. We could do it in awake, but I think just do it in here. Initialize the list by saying new generation equals new list light. And then later on, of course, we're going to return that list. And so in our light spawner, first of all, we need the reference to the cloner. So the light spawner and the cloner, they're both sitting on the goal, so they're both components. And we can just say private cloner, and in awake assign that reference by saying cloner equals get component cloner. And when we're going to respawn, what we want is we want to have the next generation. So we're going to say that lights equals cloner dot next generation. It's going to ask for a reference. So of course it's simply the reference of that lights, but it's going to give us back a new list, and that lights is going to point to that new list, and that's the one we're going to be working with from that point on. Of course, right now nothing changes. Right now what we get back is an empty list. But in here we're going to sort the lights. And for that we're going to say new generation equals old generation dot order by, type it in like that, hit control period, and it's suggesting to use system.link, which we want. Because now we have one of many very cool functions, and that is to order it based on a public field. So right now we are working with the list of light, so we need to give this one a name. It's custom to say O, but we can also say light. It's basically just trying to make the point. It can be whatever. So you can say light, and you make a fat arrow, and you say light dot, and now you can access anything that's public, such as our score. And we're going to say to list, and it's automatically going to sort the list by saying the smallest one's going to be on top and the highest ones on the bottom. Okay, now we have the new generation that just created a new list. New generation is pointing to it, and we're going to return that, and the light spawner is going to get that. Now, of course, we want to know if that actually worked, so we could say for integer I, and in here we're going to say that lights dot count. We're going to print that lights I dot score. A bit nicer way to, you could also visualize it. That just for testing anyway, we're going to delete this whole for loop in a moment. So we could say that lights dot I dot get component sprite renderer, like so. Say color equals new color, and let's see, our gate is orange. If you click on here, you see the RGBA values, and it's 0.9. So if you say 0.9, 0.7, 0.2, so 0.9F, 0.7F, 0.2F, that is going to be more or less that orange. And for the alpha value, we're going to use I divided by 100. We have 100 lights on that list. And of course, right now, I is an integer, and if you divide 1 by 100, it's going to give you back an integer, and it's going to round that, and that's going to be 0. So at least one of that has to be a float. You could say, for example, you cast the I into a float, and now it should give you back a float. Okay, let's save everything and test it out. One more thing before we hit play. click on the gate and add the cloner as our new component to it. And now we can play it. The first time they're just going to move randomly, and then they're getting sorted. And you can see the closer they got to the goal, the less alpha value they're going to have. And to be sure that it's actually working precisely, we can use the console where we're printing it, and you see that it starts indeed with the smallest number and then it keeps going up. So they're all sorted pretty nicely. That's going to make things a lot easier when, say, we want to clone the top 20%. All we have to do is get the first 20 items of our list. And that is what we're going to do in the next video. We're going to do the cloning and then, of course, removing the worst ones. So if you have any questions, feel free to leave a comment and hopefully see you next time. Goodbye.